Salam everybody, welcome to Physics with Noshe, and we're discussing this balancing experiment in which you have this ruler and it's placed on a pivot, and the pivot is at the 50.2 centimeter mark, and they place another load P, as mentioned here, which is a 2 Newton load at the 20 centimeter mark. So use this information to determine the distance x. X will be 30.2 centimeters. How? Because x is going to be the difference between this point and this point. So 50.2 minus 20 gives you 30.2 cm. How would you ensure that you have centered P exactly at the 20 centimeter mark? Well, for that, what you'll do is you will measure the length of P. This is P. You'll measure the length of P with a ruler and you will divide the length by 2. When you divide the length by 2, what will happen is you will come right at the center of that mass, and then you place a dot with a marker or anything on P. And now what you do is just align this point with the 20 centimeter mark. So आपका जो ruler है और उस पर जहाँ भी 20 centimeter लिखा हुआ है ruler पे, on that 20 centimeter mark, let's say for example this is the ruler and this is the 20 centimeter mark, all you need to do is you need to pick up this mass P and make sure that this red dot is at the 20 centimeter mark. वो automatically P जो है उस पे center हो जाएगा, because the red dot represents the center of P. So if the red dot is at the 20 centimeter mark, then that means that the load is centered at the 20 centimeter mark. So you had your ruler and you had a pivot and you placed P at the 20 centimeter mark. Now to balance this, you put another load Q on the other side and you adjust the length, and that length turns out to be 15.3 centimeters as they're telling you in the question. And now they're asking you to find out what is the weight of Q by using this equation where K, X and Y have values. K has 2 Newton value, X you figured was 30.2 and Y is 15.3. Solve, you'll get 3.95 Newtons. Make sure, because this is weight, so must mention Newtons. Now you repeat the procedure using a different suitably chosen distance X. What is a suitable distance X? So पहले X कितना था? Initially your X value was 30.2 centimeters, right? So you could move your load over here, you could move your load over here. As long as P remains on this side of the pivot, we have no issues at all. So I've said that the new distance X from the pivot should be 25 centimeters. You could write 20 centimeters. Now, the student calculates a new value of W, that's 4.04. Why the value W may not be the same when you've done it twice? The reason is two things. Number one, it could be difficult to judge the position of the center of the load every single time. Like we've placed that dot, but it won't be very easy to make sure that your mass remains at that point every single time, because you're doing a balancing experiment. So the load may slip to this side, may slip to that side. So difficult to judge the position of the center of the load, and then it's difficult to judge when the ruler is balanced, because in all these balancing experiments are very difficult. They balance for a very small time and instantly they go out of balance. So it's difficult to judge when the ruler will be just balanced, and those are the two reasons why W may not be the same. Once it's turned out to be 3.95, the next time it's turned out to be 4.04. So they're asking you to calculate the average value of the weight. The average value of the weight will be 4.00. Please make sure that you always give your answers to 2 to 3 significant figures, not more. All answers. So this answer is 4 significant figures, so that's why it's not accepted. Your answer has to be 2 to 3 SF. Question number 2, the reading on the voltmeter is 8.2 because 8 and 9 have 4 divisions in the middle, and the current value is 0.45 because this is between 0.4 and 0.5, so 0.45 amperes, and volts in the value above. Make sure you give the units. What is the temperature that we're measuring? The temperature is 19 degrees Celsius. Don't worry about the printing, because in the exam the printing will be very clear. It'll be crystal clear, so you'll have no problems reading it, as long as you understand that between 20 and 30 there are 10 divisions, so each division represents 1. So this is going to be 25, so between 10 and 20 this is 15, 16, 17, 18, and at the end you have 19, and then this line represents 20. Now they're saying you have to mark the level where you should be looking at from. So you should be looking at the lower meniscus. So you will mark your line here and you'll say this is the line of sight and this is where the eye should be. It's not necessary that you make the eye. Even if you write EYE, that's good enough. Now, question number 3, you're doing this experiment to calculate the resistance of the lamp. You have taken multiple voltmeter values 0.5, 1, 1.52, and 2.5. And for each voltmeter value, these are the currents respectively. So you have to make a table of these values. I have filled up the table for you. These are the values. And the resistance that you will calculate will be using the formula V over I. So now let me give you a tour of my graph. Usually people do house tours. I'll give you a graph tour. So the voltage begins from 0.5 and goes till 2.5. So I've taken intervals of 10, and after every 10 boxes I've written 0.5. So this is 0.5, 1, 1.5, 2, 2.5. And on the y-axis, the graph of resistance starts from 4.2 and goes to 11.9. So I started from 4 because I realized that I'll waste so much of space and I want to cover a lot of values. So I started at 4. 0 till 3 will not make any sense over here because that all of that space will be wasted. So start at 4, then 6, 8. After every 10 boxes, intervals of 2, 10, and 12. And then it was so easy for me to plot because one box represents 0.2. So 4.2 is this value and 0.5 is here. This is the first one. The second one was 6.7 on the y-axis. So this is 6.2, 6.4, 6.6. 6.7 is right above and at 1 volt. Then 8.8, 8.8 was exactly 4 boxes, 1, 2, 3, 4, and 8.8 and 1.5, and then 10.5 and 2. So 10.2, 10.4, and right above 10.4, you have 10.5, and that will be at the value of 2 volts, and the last value 11.9 at 2.5. So this is going to be 11.8 and this is going to be 12. So right between these 2 points, you have that value. And then when you make your smooth curve, your curve would be made like this. It's not necessary that all points should be on the line. As long as all of the points are close to the line, that is what matters. And what is the shape of this curve telling you? That the change in resistance, you can clearly see that the change in resistance is getting less as the voltage is increasing. Or you could say that the rate of change of resistance decreases as voltage increases. What do we mean by that? What we mean is, just have a look at the y-axis. This is resistance and this is resistance, right? So you can clearly see that this gap is small between 2 and 2.5. Whereas between 0.5 and 1, just look at the gap, it's larger. So even if you look at your table between 0.5 and 1, what is the difference? The difference is of 6.7 minus 4.2, that's like 2.5. And if you look at the change between 2 and 2.5, what is the difference? It is 10.5 and 11.9. That is like 1.4. So you can clearly see that the change in resistance is getting less for higher voltage values, and that is exactly what we're trying to say. कि जब curve यूं जाता है, इसका मतलब है resistance में change उतना नहीं है जितना पहले था. And in part E, you need to add a variable resistor in series. So complete the circuit. This is simple for the variable resistor. Just make sure your connections are complete. Now, in question 4, you have to design an experiment where you want to see how the time taken to heat beaker of water to boiling point reduces with a lid. Now, you have to design that experiment. So, and remember, you have to take it to the boiling point. They've given you a list of apparatus, and they're saying you have to plan an experiment to investigate whether using a lid reduces this heating time or not. And in this experiment, if you're wondering what to write, just remember that you have to answer these questions when you're writing. If you're answering these questions, there's no other thing that you need to write. And whenever they say a diagram is not required, but you may draw, remember that you must draw. They're just being courteous, but you can get extra marks if you draw. So here's what the setup looks like, and this is what you were supposed to draw as well. This is the bench, and you have placed a retort stand on which you have placed this beaker, which is filled with water. This is a thermometer, which is suspended with a clamp stand, and the heat is coming from a Bunsen burner, and you have a stopwatch. And then you have the same ditto experiment on this side. Actually, I should have made the clamp stand over here as well. So let me just quickly do it like this, and this is also on the bench. And this one has a lid and this is without the lid. Both cases you have a stopwatch giving heat from a Bunsen burner. And remember, you're going to measure the time that it takes to boil. Now, first question was any additional apparatus that you're using besides what they've mentioned. So we're using a stopwatch to measure the time and a Bunsen burner to heat the water. You will immerse the thermometers more than half and know the time taken in both the containers to reach boiling point. One container has a lid and the other is without the lid, as you can see in the diagram above. The amount of water in both the beakers should be the same because they asked you what things should you control. Control means what things should be kept constant. Both liquids must have the same starting temperature. That should also be the same. Next, they ask you to make a table of values. So the table will be one with the lid, the other without the lid, and the time in minutes for your temperatures. So initial temperature you will note, the final temperature you will note. Final temperature to 100 hoga because you know that you're going to take it to boiling point, but you don't have to put any values. So all you need to record in the table is that you're taking the time to go from the initial temperature to the final temperature. And actually you should be explaining what TI is. TI is the initial temperature and TF is the final temperature. And when you write, you have to use the full word, temperature. Do not leave abbreviations. They don't like it. So with the lid, you have this, and without the lid, you have this. You just have to make this table just to show them that you will put values here. No need to put values here. And make sure that you're doing it for both the containers because you have to tell at the end that whether it takes more time or less time. Now, what are you expecting? You have to draw a conclusion. We're expecting that with the lid, boiling point will be reached earlier because your heat energy losses will be less. So without the lid, आप heat देते रहोगे, it's going to take a long time to reach boiling point because heat will get emitted to the surroundings. But if you have a lid on, it will quickly boil. So the time should be less with the lid on. Which length correctly shows the extension of the spring? So always remember that you have to take the same reference points. So for example, if I was taking this as my reference point, then I should have taken this as my reference point and this would have been the extension, but there's no length that shows this change. B is not showing this. So if I take the bottom of the spring and I go to the same reference point, which is the bottom of the spring, that is showing the extension. So therefore the answer is C, cat. Now they've plotted a table because they use different loads. So they've plotted a load versus extension graph, and whether these two things are directly proportional, the answer is yes, because it's a straight line going through the origin. And the gradient of this line is 0.1744. The value is of the spring constant. Write on the value to an appropriate number of SF. What did I tell you? What was the rule? 2 to 3 SF, maximum 3. So 2 SF is fine, 0.17. And I got Newton per millimeter because if you look at the axis, this is the gradient, right? And gradient is rise over run. Now on the rise axis, what have you plotted? Newton. On the run axis, what have you plotted? Millimeters. So the unit for the gradient will be newtons per millimeter. And that is what you've written over here.